Welcome to Fast Math Solutions on Maths with EJD. In this video, we'll be considering this interesting problem to evaluate 1 plus I raised to power 10. That's complex number 1 plus I to the power of 10. Of course, this looks like something we can do using binomial expansion and all that, but that'll be a very tedious process. But interestingly, we have good methods like the De Moivre's theorem to take care of something like this. So let's see what that looks like. So to find 1 plus I, to find 1 plus I raised to power 10, right? See what you get. 1 plus I raised to power 10. We can use De Moivre's theorem, which says that z raised to power n, which is, of course, z in polar form is r into cos theta plus I sin theta raised to power n, is exactly the same thing as r raised to power n, and then the angles multiplied by n. So you have cos theta n, or you can say cos n theta plus I sin theta n. Whatever n is multiplies the angle, okay? So it means that this thing you have in rectangular form, you should convert it to polar form. So z equals I plus 1. So here A is 1, that's the real part, and B equals 1, that's the imaginary part. I means 1i, so the imaginary part is also B, such that you can get the modulus, right? Since you need R, so you can get R, which is the modulus of the magnitude, which is square root of A squared plus B squared, and that is square root of 1 squared plus 1 squared, that is square root of 1 plus 1, which is square root of 2. So that's taken care of. R is done. Then you need the angle theta. So arctan of B over A is arctan of 1 over 1. And arctan of 1 is 45 degrees, which is the same thing as pi over 4 in radian. So we have the magnitude and the direction now, and the argument, if you like. So you can now say that Z, which is 1 plus I, is the same thing as root 2 into cos 45 degrees plus I sin 45 degrees, following the De Moivre's theorem, okay? So the actual thing we need is to raise that to power 10. So Z raised to power 10, which is the same thing as 1 plus I raised to power 10 is actually this now. 2 into cos 45 degrees plus 1 sin 45 degrees raised to power 10. So following De Moivre's theorem, that means root 2 raised to power 10 into cos 45 times 10, that's cos 450 degrees plus I sin 450 degrees. Now, for root 10, right, it's like root 2 raised to power 10. That means you have 2 raised to power half raised to power 10. And then cos 450 degrees plus I sin 450 degrees. So next, you have 2 raised to power half, half times 10, that's 2 raised to power 5, and that simply gives you 32. But cos 45 degrees, how do you break this down? Now, anytime you have any angle more than 360, normally we know the 4 quadrants: 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then you're back at 360 degrees. Anytime you have any angle more than 360 degrees, you know what you should do? Keep subtracting 360 until you get into these 4 quadrants. Keep subtracting 360 from whatever angle. If you have angle 1500 degrees, keep subtracting 360 degrees until you get a number less than 360 degrees. So that means I have to do for the 450 degrees minus 360 degrees. This is 0 now. 15 minus 6 is 9. So that's 90 degrees. This is 0. So we have 90 degrees. See, that's why this one is now. So cos 450 degrees is the same thing as cos 90 degrees plus I sin 90 degrees. And cos 90 degrees is just 0. Sin 90 degrees is 1. So that's why you have here 0 plus I into 1. Then I into 1 is I. And then Z raised to power 10 is just simply 32I. Therefore, 1 plus I raised to power 10 is simply the same thing as 32I. So if you do use binomial expansion, you are going to get 32I. Or you can even type this into Google. Just type this into Google. 1 plus I raised to power 10, you get 32I. So that's what this video is about. Thanks for listening. If you have not subscribed, be sure to subscribe and then hit the notification bell so you can always get notified whenever a new video is released. See you in the next video.